Hey, good morning, everybody. Kind of a strange way to start the class on a Monday morning, but I've been working at Rankin for 14 years now, and this is the first time I've ever started a class this way. So, thank you for your patience and your understanding. And one thing that I will point out before I get started is that one of my goals this semester is to make sure that the quality that we normally offer in all of our classes is not sacrificed by doing a hybrid learning environment. I know a lot of students are concerned about safety, and I know at the same time they're concerned about quality. And my objective is to do both, and so I hope you give me the opportunity to do that, to prove that we can still maintain that quality, as well as keep everyone safe in these crazy times. So I've started this recording, and what I have open here is the syllabus, and you can find this syllabus on Inside Rankin. And I just jumped down to the first day, and on this first day, we have class introduction. So depending on when you're watching this video, you're either going to get the class introduction at 8 o'clock or you're going to get it at 10 o'clock because I have to split my class into two. There's also a lecture on the first day. And this is going to take place of the lecture, and that's going to help me. This is the only lecture that I plan on doing pre-recorded. Every other lecture will be live and have interaction. But due to the nature of this first day, this is the only lecture that I plan on this semester of being pre-recorded. There's also an orientation where we go through some student handbook information, and everyone will go through that orientation at 9 o'clock, and then there's a work ethic that we're going to discuss. But again, the main part of this is the lecture. And due to the nature of today, I've got about 45 minutes to get through this lecture. Now, everyone's gone through lectures before, probably not in this environment. But here's what I'm going to recommend with this lecture. I am going to attempt to prepare you for your written tests. When you look forward, this is a lecture on Chapter 1. Tomorrow we're going to have a lab day that's going to be lab from home. The highlighted days are in person, which are going to come down to be about once a week on average. Like here you see this first week we're meeting twice in person. We're not meeting twice a week on average. I'd say we're meeting about once a week on average. But if it's not highlighted, we'll be at home. So tomorrow is the lab day where I'm going to have essentially a handout for you to complete for a grade. Okay, so anyways, Chapter 1 lecture. Tomorrow we're going to lab on Chapter 1. And then already on Wednesday we have our first written test. So that is pretty quick. And what I'm going to attempt to do in this lecture is prepare you for that written test. The information that I provide is my comprehension and my understanding of the material that's in Chapter 1. So, of course, if you simply read Chapter 1, you're going to get some information that I might not say today. But then if you listen to this lecture, you're going to get a lot of the same information that's in that chapter, along with some additional things that aren't in the chapter. I'm definitely not going to just read from the slides. I'm not that kind of instructor. I try and provide some insight to how I see it, and hopefully that helps you. So this is not just like someone reading something to you. With that being said, the time limit is I got about 45 minutes to get through this. Just looking forward just a little bit real quick before I get into the lecture. Then Wednesday we'll have a written test on Chapter 1, and then we're going to move on into Chapter 2. We'll lecture on Chapter 2, and we'll do that live so you can have more questions and live interaction. So this lecture will be different. Chapter 2 lecture will be different. Thursday's a lab day. Again, you can see we're going into seated class on Thursday. for a lab. This will be the first hands-on lab that we do. This lab over here for Chapter 1 is more of a setup lab. This is going to be the first coding lab. And then already on Friday, we have our a test day, which includes a written test, but also your first hands-on test. And a hands-on test is where you write code. And so you can see that, again, that's going to be done remotely. And there's going to be some things that I do to quality control that, to try and discourage and prevent cheating. Okay, so that's a general plan for the first week. Again, apologize for the nature of this. I would not prefer, I know half of my class is this is like their introduction to me. I'm going to introduce myself to you. I'm going to introduce this class to you. You might have the lecture first, and then I'll do the introductions later for half of you. The other half of you, I'm going to introduce all the stuff first, and then you'll get the lecture later. So the order is going to have to change that like that. Now, part of setting up your environment is for you to what's called clone a repository, which basically means you download a folder called all coursework. And so you see I call all web dev coursework, and then your name will be behind it. And so when you clone that repository, that's to say that you're downloading a folder, and in that folder there's a bunch of other folders. Okay, so if you go into that folder, if you go into that repository that you cloned, that's where you can find these slides. Okay, and so you go into the Muroc HTML 4th edition, that's our textbook, and then you click on slides, and then you can see that we've revised all of the slides. So this is going to be the revised slides that I'm covering. So if you want to look at these slides at any point, and I do have 3 monitors at home here. You probably saw I'm in my basement here. This is my workspace when I'm at home, and so I do have 3 monitors. So I might look at this monitor, and I might even look at this 3rd monitor, or when I'm looking directly at you, I'm looking at my laptop monitor. So if my focus is changing, that's why I'm looking at my different monitors. And I do have some different things set up, like notes and stuff like that, to remind myself what to lecture over. So this Chapter 1, we're down to 40 minutes, less than 40 minutes. Chapter 1 is a broad overview of the web development, I don't even want to say career, but just at a high level, what's going on behind the scenes, what are the different components, how does it all work? This is a chapter that's heavy on the theory. It's unique in that way. Most chapters, Rankin's a hands-on school. Most of what we do is hands-on oriented. A majority of our grades are hands-on oriented. The grade weighting is focused on you doing the work more so than you taking written tests. But we do have written tests, okay? But they're just not worth as much in the grade as the hands-on portion. What you do is worth more. The code that you write is worth more for your final grade than the written test that we all know. Multiple choice written tests. So this is a unique chapter because it's just theory. So we're kind of starting in a theory environment, although we transition very quick into a hands-on environment. So this is just an introduction to web development, and you kind of look at the different objectives here. What are we going to do? We're going to talk about what are the different components of a website versus a web application. And so when I think of a website, I think of pretty much web pages in the 90s. Web pages in the 90s were just purely informational, and I use the term website. A lot of people say, well, Amazon's a website. Yeah, okay, yes, that's correct. But I'm trying to distinguish that different from a web application. right? A better description of Amazon.com is a web application. And so, I want to kind of draw a difference between, what is a traditional, what you might call Web 1.0 website, which is static in nature, never changes, versus a web application that's dynamic in nature. And every user that logs in is a different user, and they're going to see different suggestions to buy different things. And so, we got websites and we got web applications. And then there's a protocol called HTTP, which is used to deliver web files across the internet. And we'll dive into that. What is HTTP? What is a request? What is a response? How does that work across the internet? Again, the difference between static web pages versus dynamic web pages. Static web pages, I think of Web 1.0 in the 90s. Dynamic web pages, I think of Web 2.0. I think of Amazon. I think of Facebook. I think of Twitter. Now, where users can have accounts and they can create their own, Facebook pages, and they can have e-commerce and all those things. So dynamic versus static. Then we'll dive into what is HTML, what is CSS, and what is JavaScript. Those are your three fundamental languages: HTML, CSS, and JavaScript. I should mute my phone. Bad teacher. Mute your phone. Okay. Three fundamental languages for doing anything on the web. And that's these three languages right here that I'm highlighting. These are the languages that we're learning this semester, this 80 days from August until the middle of December. Then we're going to talk about how to actually deploy a website to the internet. So we're going to build it on our laptop and then get it out on the internet. How do you do that? The different pieces of a URL. You've probably typed in a URL, but if you really break it down, what are the different components or pieces? And then we're going to talk about internet usability, cross-browser compatibility, accessibility, search engine optimization, and responsive web design. Important concepts that really are at the focus of this entire class. And so we kind of introduce these topics here, and then throughout this semester, we talk about how to make your website more usable, how to make your website more cross-browser, how to make the information more accessible to users on your website, how to make it, how to optimize it so that Google ranks it at the top of the search results, and how to make it look good on tablets, cell phones, and so forth. Silly picture here, but components of a web application. As a client, we have all these different devices, and the client has typically the web browser on it. So when you think of, actually, before I start here, if I didn't mention this already, I know I mentioned that I'm going to try and prepare you for the written tests, and so it might be in your benefit. If I say something is important, you might want to write that down. You might want to take some notes. So, get out a pen and paper. And if I say something is important, or if I repeat myself a couple times, if I repeat something a couple of times, it's important. And when I say that, it's more than likely going to be on your test in some way, shape, or form. And so when you think about components of a web application, these three devices here, be it a desktop, a laptop, a tablet, a smartphone, whatever it is, those are all referred to as the client. And the client is the device that has the web browser on it. The web browser is obviously what we use to request a website. And to request a website, you go into the web browser and you type in google.com and you hit enter. And then that's the example of the client being the device that you're on. That's the client. requesting a website. And then it goes through the cloud of the internet. That's whatever. That's the graphic they use to represent the internet. And then the web server ultimately is the device that receives the request. So it receives the request and it says, okay, this smartphone wants the files for the website. And it sends back what's called a response. Now that web server, I've used two terms here, client and server. The client is the device that has the web browser on it, and I would tell you that's important. Okay, so the web browser is the client. It makes a request. That request is received by the web server, and the web server responds with the files. And with a response, it sends the files back through the internet. The device then receives those files, and then the web browser renders the files, which is just to say that it draws the website. You could think of it as drawing it, but it basically puts it on your screen and formats it and puts the content where it needs to go. Now, the web server typically runs a software like something called Internet Information Services, or IIS. On a Windows machine, on a Linux machine, you might run something called Apache. And so it's just a piece of software, but at the end of the day, these are all computers. The clients are computers, the servers are computers, and the word client and server, that's just a relationship. The client is the one that wants something, and the server is the computer that has something. In this case, that something is a website. But a client-server is just a relationship. And so you could have client-server relationships with files. You know, the client could be a computer that wants a file, and then there's a file server that has the file. Think of Dropbox. Dropbox, ultimately, there's a computer with a file on it, and then you want that file. So the client is your laptop, and you go onto your Dropbox and you double click it, and then the server responds with that file, right? That file's not on your computer. So client server is just a relationship here. The internet, okay, now there's a difference between the internet and the World Wide Web. Again, this is kind of academic, right? So a lot of people use that in the real world. They use those two terms interchangeably, right? But the internet is more of the plumbing. Okay, more of the hardware. The internet is more of the hardware, whereas the World Wide Web is more of the software. The World Wide Web is made up of things like HTTP and FTP and IIS. So the World Wide Web is really how you send files back and forth with software. And then the internet is more of the plumbing or the hardware. And so the internet is made up basically a bunch of wide area networks. You see it in the graphic here, WANs. Okay, a bunch of WANs that are connected together. And ultimately, they're connected together through their internet providers. So you see the WANs here connected through IXPs, and IXPs are connected, are the internet providers. But no one owns the internet. The internet is open source, if you will. There's no central body that owns the internet. It's just a bunch of networks connected together. It's just a bunch of networks connected together. You think as your home network is a LAN. Ultimately, that WAN is connected to the internet provider through the wide area network. So, again, the best way to think of the internet is a bunch of WANs, wide area networks connected together. Now, the difference between a LAN and a WAN is just geographical space. So a LAN is typically smaller. Think of your home or maybe a business, and they're all connecting into a single router. And then when you start connecting many of those routers together, Like you think of like your city, if you got a bunch of homes and you connect all those homes together, it's a little bit more broader scoped. And so that city might be a wide area network. It's just a bunch of networks connected together in a city. And so it becomes a little bit wider than just the local ness of your home. And then ultimately the internet providers, things like Charter and Comcast. I have Charter. AT&T. There's another big one, but it's not coming to mind. So the idea of wide area networks connecting together that make up the internet, you want to know that. I'm not sure how this camera is focusing, but I just gave the thumbs up. You want to know that. That's important. So again, maybe repeating myself here, the hardware side is the internet. The software side is more of the World Wide Web. And when I say the software side, I'm talking about the protocols such as HTTP. I'm talking about the languages that come in and make up the World Wide Web. The languages like HTML. HTML is a language that we're going to learn to write. And so it's more software based. All right, static web pages. Again, I think of Web 1.0. I think of websites in the 90s. These are becoming less and less. Now, I will say that there are more of these on the web than most of us realize, even today. Because if you are a small or medium-sized business, you probably can't afford to have your own. Well, and I take that back. It's becoming easier with tools like Shopify as a small business owner to have your own e-commerce website. But there are enough small businesses, maybe even medium-sized businesses, that just have websites for informational purposes. They want to be found on Google. They want people to know their hours of operation. They want people to know their business location. They want people to know their phone number. They want to know their services that they offer. And so static websites were really in the 90s, but there's more of them on the internet today than you might realize. And the reality is, most of us probably know somebody that would like a website of this nature, purely informational in nature. You know, there's no logins here. There's no e-commerce here. It's just informational. You can't search for products. There's no databases. So this is Web 1.0, and the main thing here is that every time you go to the site, you get the same site. That's why it's static, right? Every time you go, it's the same site. Now, again, we talked about this a little bit here already, but a client is any device with a web browser on it. So cell phone, tablet, laptop, computer, right? The client says, with a request, hey, I'd like some files to show me this website. Behind the website, there's a bunch of files. Sometimes 10 files, sometimes 30 files, a bunch of files. The web server, which is just a computer, and it's just a computer running some software, receives that request and says, okay, here's the files. And that's done with an HTTP response. And so HTTP is the protocol of the World Wide Web. It's that software that has the rules for sending files back and forth. So the rules for sending files back and forth, it's done with this software, and obviously an HTTP request is a request for information, and an HTTP response is a message back to the client that includes the files that the client is requesting. And so the web server is just a computer that stays on all the time, and it hosts those files. Obviously, if a web server were to power off, then the client wouldn't have access to those files. Okay, and so the HTTP request comes from the client. The HTTP response is sent from the server. Okay, pretty straightforward, but it's important. Okay, request from the client, response from the server. Okay, now the other part here that's important, we'll mention this, you'll find this somewhere on the test, that the web browser makes the request. The web browser renders the HTML. When I say render, remember that really essentially means it paints the picture, it draws it on the screen, right? It puts the pictures where they need to go. It makes the text as big or as small as it needs to be. So the client also renders the HTML. Okay, 20 minutes. Dynamic web pages. This is Web 2.0, okay? Man, Amazon. I wish I would have invested in Amazon. Incredible business. One of the biggest web applications on the internet. Used to just sell books. Then in the 90s, they started selling other things. Small businesses are on Amazon. That's the thing that people don't realize, is that Amazon is not like a Walmart. I know Walmart.com is trying to compete with Amazon.com. And the reason why I don't think Walmart will ultimately ever take over Amazon is that small businesses operate on Amazon.com. If you want to sell watches from China on Amazon, you can open up a small business yourself and do that on Amazon.com. And then you can become an authorized retailer through Amazon. And then it almost looks like, to the end user, these watches are coming from Amazon. A lot of people do that. But it is not a Web 1.0 site. This is a Web 2.0 site. And if you ever want to talk about Web 3.0, that's today. That's what's coming in the future. This is more of a theory thing, this Web 3.0, but it's supposed to be a trusted World Wide Web. Right now, it's the wild, wild west. You can't trust information on the internet. So Web 3.0 is going to be more of a trusted environment. So Web 1.0 is static sites. Web 2.0 is like now users can interact and have accounts and make their own pages and shop, e-commerce. That's Web 2.0. Web 3.0 is coming, and it's going to be more of a trusted. You're going to be able to trust information better. It's going to be a beautiful place whenever it shows up. If you want to talk about Web 3.0, I'd love to do that. Now, this picture is wrong, and I will tell you that it's important to understand that how this picture is wrong. In a application, in a web application, or what they call it a dynamic web page on this slide. This is a Web 2.0 website. The client actually makes a request to the application server. You can see on the slide where the client looks like it's making an HTTP request to a web server. But in reality, the client makes the request to the application server. Again, that's important. And you can see the application server might interact with a database. It might need to say, okay, you gave me a username and password. Is that a good username and password? And those username and password credentials might be stored on the database. And so you might need to load some information from the database, and then the application server renders the it responds with the HTML. Okay, and so when you have a dynamic web page, the traditional web server, be it IIS, isn't necessary. You really just now let me double check something here. I took some notes and I'm second guessing something here real quick. Yeah, I was wrong. That's what I said. It's not necessary. It's still there. The web server is still important. So I knew why I said that I was wrong. The application server interacts. It receives a request. So the client sends the request to the application server. It can then interact with the database. It then sends HTML to the web server, and the web server responds. Okay, so if we're following the flow here, client to the application server, maybe to the database server, but then the application server has to give the HTML that is the result to the web server, and then from the web server to the client. So that's that page. Hopefully, I haven't tested this, but hopefully you can hear. This is a Linus Tech Tips video. If you've heard of Linus Tech Tips, I'm going to pause my recording here just for a split second. 1 second. Okay, I just wanted to get my video loaded up here. So I'm going to just let Linus talk for a few minutes. It's just 2-3 minute video that continues on the explanation of the internet infrastructure. He's a good YouTuber that I like to listen to, and he does a good job of explaining. So here he goes.
When you send out a tweet about a new video card you can't afford or how great the last episode of Tech Quickie was, have you wondered what happens? I mean, sure, we all know that it goes out onto the internet, but much like flushing a toilet, most people don't know exactly what happens to their chunks of data after they post something. So where exactly does it all go? Well, to understand the answer to this question, it might help to keep in mind that the internet is not owned or even governed by any one group of people. I said not owned by any one group of people, but rather it works as a distributed system made up of lots of smaller computer networks owned by various ISPs, universities, governments, and other organizations that are linked together through what are called peering agreements. But Linus, hold on a second. If no one's really running the internet, then how does it stay working? Do we even know where it goes? There are organizations that help coordinate and direct internet traffic so that compatibility is maintained everywhere from Ottawa to Oman. Probably the most well-known of these groups is ICANN, which maps IP addresses to internet domain names. So when you punch in, let's say, linustechtips.com in your web browser, that actually isn't enough information for your computer to know what website to show you. So what happens is your ISP, or internet service provider, directs it to a DNS server which matches what you typed to the IP address that corresponds to it, so you can connect and keep consuming the awesome videos we create. But once you do that, then how does the content itself get to your PC? One of the internet's most defining features is that it is packet switched, meaning that all data is broken up into little, packets, and then reassembled once it arrives at your computer. And while the idea of shattering and then reassembling something every time you need to move it won't make much sense for things like, human arms, the advantage of this approach for computer data is that it allows each packet to take the most efficient route possible. So if everyone in the town next to you where your traffic would have normally been routed through starts streaming Game of Thrones at exactly the same freaking time, congesting any nearby nodes, causing some of your much more important My Little Pony packets to slow down, the remaining ones can be easily and dynamically rerouted via another path even mid-file, so your internet speeds stay high. And because packets contain, in addition to the actual content, identification information that ensures they are being sent to the right place and that they can be properly recombined later on, normally none of the data ends up as a corrupted, jumbled mess either. Speaking of jumbled messes, if you've ever tried to do something as simple as copy a file to an external hard drive on a Mac, and then carry it over to a PC and open it, you're probably wondering how users on different operating systems, on different machines from different parts of the world, all manage to use the same internet. Standards bodies come to the rescue here again. They make sure that the same fundamental languages and technologies are used throughout the globe, including W3C, which is in charge of things like HTML and CSS, the languages that your web browser will interpret into something your computer can understand. So I hope this helped give you some idea how the world pulls together without a single guiding force to give us this awesome tool for arguing on Twitter and reading half-baked political opinions. Speaking...
So that was just a little bit more detail on how the internet is, how it works, the hardware behind the scenes. One whole entire track of educational study that we offer is networking, and so that's like a 3-minute overview of a lot of what they do. And again, that's not critical for our everyday. It's not like we're going to be dealing with packets and understanding hops and everything like that across the internet and how information is taken apart and reassembled on the other side. But it's just good to know, and I would encourage you before we move on from chapter 1 to watch these second links, because this is a little bit more specific for web developers, which is who we are. And so this is about 30 minutes in length. So again, before we move on from chapter 1, this is a really good overview, these two videos. Now, web browsers, again, that exist on the client side, this is a pretty updated market share of the different popular web browsers, Google Chrome being the most popular. I will tell you that as web developers, if you use Internet Explorer, Microsoft Edge, Microsoft Internet Explorer, those are stereotypically hated in our industry. They've caused a lot more headaches and problems Microsoft has with these browsers. They've certainly gotten a lot better through the years, but just even go back 5-10 years ago, and they were not very compliant with web standards. And so that's the reason why Internet Explorer in 2006 was the number one browser, and today it's got probably less than 7% of market share. And so Google's Chrome is by far the popular. That's what I use. Safari, Firefox is almost dead. Firefox has been trending in the wrong direction. Opera, Safari's there as your iPhone browser, and obviously you can see a lot of that traffic there just because a lot of people have iPhones. There's kind of the history of Chrome's rise and basically everyone else's demise. With the exception of Safari, which has gained a little traction there. When you have a dynamic website, you need some additional languages. The 3 languages that we're going to focus on this semester is HTML, CSS, and JavaScript. But when you have a dynamic web application, you need a programming language. And so you could see here a server-side programming language. You need something else besides the 3 that we're covering. Popular languages are Python, Java, C#, PHP, Ruby, and JavaScript. Rankin's curriculum, I love this chart, and this is, as you can see, a survey from 2020, so it's nice and updated. JavaScript is the dominant language of the web. It's only become more dominant in recent years, and that's what our curriculum is focused around. You will have an entire semester of studying JavaScript, a semester and a half essentially. You'll have a semester and a half of just studying JavaScript. So half of it this semester, 40 days roughly, will be JavaScript, and then you'll have another 80 days. Now, JavaScript can be a server-side language, but that was more of a recent thing. HTML, CSS, and JavaScript historically were purely client-side languages. And okay, so I'm saying a server-side language versus a client-side language. What's the difference? where is the language that we wrote processed? In other words, HTML is a client-side language because the web browser processes or renders the HTML and draws it on the screen. So my laptop has the browser on it. Therefore, my laptop does the work to draw the HTML on its screen. So HTML is a client-side language. CSS is a client-side language. JavaScript historically was always client-side until recent history. They figured out a way to get JavaScript on the server side, which is part of its dominance nowadays. Now JavaScript can be both client-side and server-side. So server-side being, that the processing happens, the Java processing happens on a server, not on the client. The Python processing happens on the server, not the client. JavaScript is unique because it can really be server-side or client-side. And when you look at, some things that JavaScript can do on the client side, you get things like image swaps, image rollovers. You get things like form validation when you're filling out a web form, like this is my name, this is my address, this is my credit card number. And you click submit and you get the little error messages. That's client-side JavaScript many times. Calculations can be done. So, how much tax and how much shipping are you paying for this? That's oftentimes client-side JavaScript. And so when you have client-side JavaScript, it works the same way as the HTML on a static website. You make an HTTP request, and if there's JavaScript involved, then the web server can simply respond with the HTML and respond with the JavaScript. So web servers can respond with more than HTML. They also host images, they host videos, they host HTML files, they host JavaScript files. So web servers host a little bit more. Now, I think it might be a good point to talk about what is HTML. And I'm running out of time, so I need to either go long. This lecture might go long, and that's fine. That's what I'm going to have to do at this point. HTML is used for two purposes that I think of. The first purpose is for content. If there's content on the web, that content is put there by HTML. So what do I mean by content? I'm talking about your images. I'm talking about your headings, your paragraphs, your videos. So HTML is used for content. That's the easiest thing to remember. It's also used for structure. When I'm talking about a web page structure, I'm talking about, okay, how big is the header? Up top, you got the header. How big is it? How small is it? How wide is it? You got a footer. You got a sidebar. You got a nav bar. You've got some content sections. And so HTML is used for both content and structure. JavaScript is used on the client side to make the page a little dynamic. CSS is used for the styling. CSS stands for Cascading Style Sheet. And so that middle word, style, is what the page looks like. So HTML puts the words on the page. CSS says what color the words are, how big the words are. Are they maybe bold and italic? You can use CSS to do that. And so HTML, structure and content. CSS is style. You could also say that's the formatting. So that's the language that you might see, on a test, that CSS is used for formatting. JavaScript is used to make a page dynamic. And so here's a couple things of making a page dynamic. That interactivity, the image swaps, the image rollovers. I think of like, you go to a page with an advertisement on it, and it's just every 3 seconds or 5 seconds, it's just swapping ad bars, it's swapping images on an ad bar. That's interactivity, image rollovers. Data validation I talked about on your forms. You got little information in accordions. You click on it and it expands and contracts, and you can. That's obviously an accordion. Asynchronous JavaScript and XML. That's an example of how JavaScript is really embedded in other technologies. So Ajax is a technology and language of its own, and JavaScript is the root of a lot of other languages, and so that's another reason why it's so important. You could see asynchronous JavaScript and XML. What Ajax is, it's a great technology. It's a way for part of the web page to update without the entire page having to do a refresh. In the old days, if you could think back to Google Maps or even MapQuest, if you guys are old enough, you might remember, if you would zoom in on the map, the entire web page would have to refresh. That was before Ajax. Now you can zoom in on the page, and the client makes a request to the server, receives that response from the server, and then you can just refresh that part of the page. And so Ajax allows that to happen. So you can zoom in on the map, and it doesn't have to do a full page refresh, just the map gets bigger. Other common examples of Ajax are, I think of Google. When you start to type and Google suggests something, that whole page isn't refreshing, but you're getting a dynamic updating part of the page. I think of you're sitting there on your email, and without refreshing the page, a new email pops up. That's Ajax. Again, HTML is used for content and for structure. This is an example of HTML. Again, this is just the theory. We're going to get into actually coding HTML this entire class, but this is what HTML looks like. There's really not too much that you have to memorize here, but just FYI. HTML by itself is pretty ugly. This is a pretty ugly web page, and I will tell you that we are going to be making ugly web pages for at least 20 days or so. By the end of the class, we'll make very pretty web pages. But in the learning process to get from where we are to where we need to be, we're going to make plenty of ugly pages. So bear with me with the idea that we will make some good-looking sites. Our sites might look pretty ugly just like this in the beginning because we're just learning the fundamentals of HTML. So HTML is used for structure. CSS is the style or the formatting. We covered that. Let me take my notes here, make sure I'm not missing anything that I want to cover. I did cover that JavaScript is a client-side language or a server-side language. What we're studying in this class is the client-side JavaScript. In your third semester, you'll study server-side JavaScript. And that's, you might have heard of things, maybe, if you're kind of been in this space or at least paying attention, Node.js, Angular.js, React.js. Those are all server-side. Well, excuse me, several of those are server-side JavaScript. On the client, though, your web browser is able to render the HTML. Each web browser has its own JavaScript engine. Kind of a cool way of saying it. It's got its own JavaScript engine. And the web browser has this piece of software called the JavaScript engine that runs the JavaScript. Now, what's really interesting to me about this, that's part of the reason. If you think of the stereotypes behind web browsers, here's the stereotypes. Firefox is secure. So if you're one of the benefits or reasons people like Firefox is it's open source, and therefore when there's a bug, they can often fix it quickly, and it's not vulnerable for a long time. Internet Explorer, no one likes. That's a stereotype. Chrome is fast. People like Chrome because it's fast. Part of the reason why it's so popular. One of the main reasons why Chrome is faster than the rest is that Google made their JavaScript engine inside of Chrome very efficient. So Google made a very efficient JavaScript engine that runs JavaScript faster than Firefox does and runs JavaScript faster than Internet Explorer does, therefore making your pages faster. So I wanted to come back here and talk about that JavaScript engine, and different browsers have different JavaScript engines, just like different browsers have different HTML, I want to call it engines because I'm calling them JavaScript engines. Gosh, I got to think of the term. Rendering software. So some browsers render HTML faster, slower, and so forth. So it's just software built into the browser that runs the HTML and draws the picture, or that runs the JavaScript. I got to think of that right term for the HTML because it's not called an engine. This is when you have these different files, HTML and CSS, you need to get them to work together. And so the way that you tell the HTML to work with the CSS is in blue here. There's a link tag. These are called tags. And there's the link tag that tells the HTML to work with that particular CSS. Okay, go through my notes here, make sure I'm not missing anything. Okay. Okay. Doing good. This is what CSS looks like. Again, we're going to be studying this all semester. If this looks like, complete gibberish to you right now, it probably should, unless you've done this before. You start using CSS and the page starts to look a little bit different. If you think back here, this is just pure HTML. And, here we've got some columns. You got, the book in one column and some text in another column, and you got a border going on here. So it looks a little bit better. Still pretty ugly, but just some fundamentals here. So the couple of, introduction to HTML, introduction to CSS. This is the Mozilla Developer Network. A couple of resources for you to look at later. We will be writing our HTML and our CSS in Visual Studio Code. So when tomorrow or tonight, whenever you run through the Setting Up Your Environment PDF, you'll be downloading Visual Studio Code, and that's what we'll be using. That is the most popular today in 2020. Now, 3 years ago, 4 years ago, it used to be brackets. 10 years ago, we used to use Notepad. But there's always been multiple tools that you could use. But just as far as today, the most popular, Visual Studio Code, that's what we'll be using. When you start working with more server-side languages, you might have some more options as far as these IDEs versus a text editor. Okay, is something here. IDEs are just software with more tools built in. Okay, and so text editors are just don't offer as many tools to help you write code, versus IDEs offer more help. And so this is like more bare bones, and this is just more assistance. Again, we're using Visual Studio Code, and some of these you use for server-side development as well. You can. Now, FTP, all right, File Transfer Protocol. What we're going to do is we're going to make a website. We're going to make a website on your computer first, on your laptop. And then when that website is ready to, quote-unquote, go live, you're ready to put it on the internet, you need to take the files from your laptop, and you need to transfer them to a web server. So they need to go from one computer to another computer. And very commonly you do that with what's called File Transfer Protocol. And FTP is, again, it's just a protocol to send files from one place to another securely. And so what we will use is FileZilla. Now, I think I have you download FileZilla in this Setting Up Your Environment. If not, I need to add that in there. Parts of a URL. Okay, so you need to go to a website. Most of us type in the domain name, and we don't even type in www. We don't even type in HTTP. We just type in the domain name minus the World Wide Web. What our browsers do is our browsers are smart enough to add in the different pieces. Our browsers say, okay, well, it's obviously HTTP because it's always HTTP. www. Because that's pretty much always there. HTTP, again, is the protocol portion of the URL. The protocol is basically the set of rules that dictate how we send files across the World Wide Web. Okay, it's the main protocol of the World Wide Web. The domain name is what you purchase. You have to buy a domain name. That doesn't come free. So, $5-10 a year, something like that. And then the path is, if you don't want to go to the main page of the site, you can provide a path to go to a different page. And so the path, typically, this first part here is a folder on the web server. And then inside of that folder is a particular HTML file. And so here's a link if you want to study more about the different components of a URL. Now, there's the internet, as we all know. There's also an intranet, which is also some theory in this chapter, which is important to understand. The internet is more of a public space. The intranet is more of a private space. And so you think about your home. You got the intranet at your home. The internet is more public. And so it really comes down to the addressing that Linus Tech Tips talks about, where every internet address is a public space. Every intranet address is a private space. And so there's what's called an IP address. When I'm saying an address, it's an IP address. And you can think of a public address like your house's address. That's a public address. But then if you think, okay, well, inside of my house, I'm going to give each room a number. Room 1, room 2, room 3, that's private to you. So it's kind of the same way here. If it's a private address, that's private to you. On your local network, private. But if it's something on the internet, like a web server, that's going to be a public address. So if you want to go to a web page on the internet, really just type in the URL. Okay, or you click on it from one link to another. Obviously, that's a big part of what makes HTML successful, is that HTML is a bunch of pages that link together. And if a page is good, you can link to it from your site and reference that page. And so HTML is really just a bunch of documents that link together through hyperlinks. Now, if you're accessing a page on your own computer, more on a private level, got a fly buzzing around in my basement. Sorry about that. You can open it up through your text editor or your IDE. You can browse to it. You can kind of go through your file explorer and find the HTML file and double click it there. Or from your browser, you could click on File Open and open it that way. Probably you're just going to, open it up through your IDE. That's what we're going to do in this class. We're going to work in Visual Studio Code, and then we're just going to launch the page right from within Visual Studio Code. Just some tips as we name our files and name our folders, because back here we learned that the folders and the file names might play a part of our path. And if other people are going to remember any of that, we're going to have to make this pretty simple. Like, we don't want hyphens, we don't want underscores, we don't want complex numbers, we don't want really long folder names. And so, as you can see here, the path might be included, and so there's several suggestions here. Lowercase letters, no spaces. So if you have to include an underscore or hyphen, it's better than a space. Avoid uppercase letters. And then just be clear with your naming convention, because again, that helps out search engines and it helps users of the site. For the most part, you can go to any web page and view source. And so here's Chrome, and you can inspect or right click and view page source. And when you view the page source, you're going to see the HTML. You can go down here and see all the HTML. Now this is messy, not clean at all. There's actually quite a lot going on here, so this might intimidate you, but HTML is not nearly that hard starting out. A better tool than inspect, which, because it's a client-side language, we can inspect and see the code. Server-side languages, you can't do that. Server-side languages are more secure for that reason. You just can't inspect the code. Okay, but here in Chrome you can inspect, and this is a little bit nicer. This is a little bit cleaner. You can see some formatting going on. I can kind of collapse these different areas. I can kind of tell what's going on, and I can see the CSS over here. And I see the HTML over here, and I can click on this and see, okay, what's the HTML for this inside Rankin? I click on that, so I click on the inspect tool. I click on inside Rankin. And it takes me right to the HTML for inside Rankin, and it takes me right to the CSS for the inside Rankin. And so notice if I get rid of that color, see what happens to my links? All my links go blue like they are by default. But here we wrote some CSS to change all of our links to be red. And so this inspect tool is a lot better than view source, but you can view page source. And you could do the same thing with view source on the CSS file, and then kind of give you the path to the CSS, and you can open that up. Okay, last section. We're at about an hour and 15 minutes here. I need to remember how long this is, so I know how long it's going to take on your first day. Usability, cross-browser compatibility, accessibility, search engine optimization, responsive web design. These are 5 topics that we're going to cover at the end of the PowerPoint here. Usability is exactly what it sounds like. Usability is why iPhones are great. iPhones are great because they're usable. They're intuitive. You don't have to read a manual and then use the iPhone. For the most part, you just use the iPhone. People understand how to use it without instructions. Good websites are the same way. Some components that make a website usable, easier to use. The old days of newspapers, they had a concept called above the fold. And in a newspaper, you would sell it in a little machine, and it's funny. You don't see those very much anymore, but you know what I'm talking about. You throw your quarter in, you pull the newspaper out. And they would display today's newspaper in the glass, and you would only see what was considered above the fold. The internet web pages have the same concept. You want to put all your important information above the fold before the user has to scroll. So websites have, above the fold, you don't have to scroll down. So that's one thing that makes a website easier to use, is you want to put critical information above the fold. The more scrolling a user has to do to find the information they're looking for, the less likely they are to do it. You want a nice consistent nav bar. Notice this nav bar here? That nav bar is not going to change. Okay, a lot of beginners make that mistake. They have a nav bar, and you click on the furniture tab, and then the furniture tab would disappear. Well, that's not good. You want the nav bar to be consistent. So you want a consistent nav bar. You want to use above the fold. You want a consistent nav bar. That nav bar is going to be at the top of the header, so it's going to be towards the top of the site. So nav bar in the header. By the way, this is all important, right, to understand what makes a website usable. And you want to brand yourself. So another good thing to do is to brand, with your logo up in the header. So you got a logo here, and you got this fave icon. This is called, right, for the page, but definitely a logo in the header. And these are all things, some concepts that makes a website more usable. Right, so it makes it they can find the information quickly with above the fold, and they get to the information easily. Yeah, the thing about website users is that we have short attention spans, and so if you don't find what you're looking for quickly, you click back. You don't like to scroll, and they move quickly from page to page. Oh, I already covered that. That's good. Cross-browser compatibility. Cross-browser compatibility is an important topic because we want to write code one way and then ideally have it look as close as possible in all the different popular browsers. So we don't want to write it one way for Internet Explorer, another way for Chrome, another way for Firefox, another way for Opera. Okay? So the way that we do that is by writing clean code. If we write valid code, by clean I mean valid, when you write valid code and use modern browsers, you're going to get the best amount of cross-browser compatibility. Now, the goal is always to be perfect, but you'll never be perfect because there's only so much in your control, but it's a lot better today than it used to be. So cross-browser compatibility means your site looks very similar in all the different browsers, and that's a good goal for us to have. Another topic is accessibility. So we've talked about usability, we've talked about cross-browser compatibility, and we have accessibility. Now, accessibility is the idea that regardless of the user's disability, if you have a disability, they should still be able to access the information on your site. And so depending on where you go to work, you might be governed by law to make your website accessible. Specifically if you go to work for the government. Government websites are stereotypically very boring. They're very, very boring. Anyone that's been on a government website knows I'm telling the truth. And they're boring. They're just put the information out there. Well, the reason why they're boring is because by law they have to be made accessible to screen readers, right? So if you're blind, screen readers have to be able to access the information. Users with motor skill issues, so I'm just shaking my hand because if you have shaky hands and you have a hard time using the mouse, that's part of using making a website accessible, making it easier to use for people with being deaf, being blind, having shaky hands. These are all disabilities, color blindness. So these are some laws that say, you might have to, by law, make your website information accessible. But it's just a good concept regardless, is we want all of our websites to be accessible so that as many people can access them as possible. Again, there's visual, hearing, motor, and cognitive. So I talked about visual being blind, hearing being deaf, motor skills with our limbs, and cognitive being mental, essentially mental disabilities. Right. Then we got responsive web design. We're going to learn to build our websites in a responsive way. That means we write one set of code and it responds to the device and the orientation of that device. And so it's going to look good on an iPhone. It's going to look good on an Android. It's going to look good on a tablet. It's going to look good on a widescreen monitor. It's going to look good on a monitor from the 90s. And so the look and feel's consistent, and we're going to use tools like media queries, scalable images, flexible layouts. These are all tools that we're going to use to make what's called responsive web design. So we talked about accessibility, we talked about usability, we talked about responsive web design. All right. Right, and again, the big thing with responsive web design, the iPhone came out, I think, in 2007, so it's been 13 years, and we're doing more and more browsing with mobile devices, and so we have to make our websites look good on them. So responsive web design became a popular topic, 10 years ago when the iPhone came out in 2007, didn't become popular for about 3 or 4 years, but it took over pretty quick, and then all of a sudden everyone's browsing the web on their iPhone. So the industry had to respond, and so these are the tools that we have for that. Hey, that's the end of the first lecture. So normally at the end, I take this as a time for questions. I get feedback from my class. I'll ask you the components of a web application, HTTP requests and responses, and I'll get some feedback. What's the purpose of JavaScript and CSS? Describe usability, cross-browser compatibility, accessibility, SEO, search engine optimization. Now, SEO is one topic that we missed a slide for. Search engine optimization, that's why we got a review. Search engine optimization. Search engine optimization is how you get your website found. There's a movie, and I can't even say that I've seen it in a long time, Field of Dreams. And my favorite quote around search engine optimization is kind of like that Field of Dreams. The popular quote from that movie is, "If you build it, they will come." And I think they were talking about a baseball field. But as far as the web is concerned, if you build it, they will come is completely false. And what that means is that just because you build a website does not mean that you'll get traffic to that website. You have to optimize your website for search engines. Obviously, Google is the search engine to optimize for because everyone goes to Google. It's not even close nowadays. Other search engines are Yahoo, Bing. I think there's GoDuckGo, something like that for security and privacy. There used to be one in the 90s called Ask Jeeves, whatever. But you got to optimize your website. So you got to code your website using certain patterns and certain techniques to make your websites friendly to search engines and let your website be found. So that is the end. Now, your reading assignment, I'm not using this perusal, so I need to update this. So your web assignment or your reading assignment is to read chapter 1. So again, I lectured on chapter 1. I covered the important information. Any good teacher will tell you that repetition aids comprehension. Repeat this information. Read it. Very important to read it tonight, right? That will help you do better on the test. So read chapter 1, and then your labs are on Inside Rankin. Now your labs, tomorrow's the lab day. I'm going to walk through with everyone getting their environment set up. So the labs for chapter 1 is to complete the setting up your environment document that's on Inside Rankin. As far as your homework is nothing to grade. Your homework is just to read chapter 1. Read chapter 1 and complete setting up your environment. And that's the end of my first lecture. I'm going to stop the recording. Thank you for your patience with this. Again, future lectures will be different. Hopefully you found this useful. Have a good day. Oh yeah, I decided I'm going to do a sign-off. So my sign-off is You're all good people. Have a good day.